Digital screens are, they're really fun to make procedurally, and they're also very intricate. All right. The thing is that every digital screen is made up of individual pixels, and each pixel has three colors. Is made up of three colors: R, G, and B, red, green, and blue. And these three colors change their intensities, their strength, or their saturation and values, uh, to give us this whole wide range of colors that we are able to see on a digital screen. So that's what we're going to be making in this video, and we're going to be making a fully procedural digital display screen that will in which we can change the number of pixels and also control the resolution of the image in relation to the pixels. It's going to be super realistic and it's going to be fun to make. So welcome to this episode. If you're here because the thumbnail or the title of this video said, a digital display screen material, you're welcome to follow this tutorial. And but this is actually the final part of a photorealistic TV model tutorial series that I've been making over the past few weeks. And if you wanna, you can check that out as well. Also, a big shout out to my friend Hadar Nesher, who's the person who came up with this material, with this entire node setup. And you can check out his amazing works on Instagram. I've linked it in the description below. Guy's genius, has great works. So this is where we left the TV in the previous parts. We applied the material everywhere, and in the previous part I forgot to apply the material for these things, but I just copied the same metal material over there, so it's nothing great. And we just have the material for the screen which is left to do. And you know what, I'm actually going to be doing this in a new blend file, so that you get the material alone and nothing else. So I'm gonna start with a plane, and I'm gonna scale this along the x-axis and also enable this. All right. If you can see that this plane is two-dimensional. All right, it's not three-dimensional. There's the x-axis and the y-axis. There is no geometry along the z-axis. You can see that if I if I go into front view, you can see that it does not have any head. So the z-axis is useless over here. I'm telling this because when we come to the nodes, you don't want to be using the z-axis coordinates. So can switch to rendered view, and I'll disable these, and I'll have the gizmos because they will be helpful. Alright, I'm gonna add a new material, and I'm going to delete the principal PSTF because we don't need that for this tutorial. And we're going to start. So I'm going to make this a very simplified explanation, so I'm not going to be going through the technical side or the math side of all the nodes which I used, but I'm just going to give you a simplified explanation that is easy to understand. All right. Okay, so when it comes to a digital display screen, there are two things which are needed. One is the image and the other is the pixels. So this will be our first step. Our first step is to actually bring in an image texture over here. Let's bring in one. All right. So this is the image that I've brought in. It's thumbnail of the of one of the previous parts, and make sure that you apply the scale over here. And just in case you are unwrapping this, you might have to go into the UV editor, and sometimes you might have to play with the vertices to align the screen with the image. Just a heads up, in case some of you are in case you unwrapped this and it's like this or something like this, you will have to go and manually adjust the UV island. Oh, and it's better to save the file. Alright, and we're gonna go into the shader editor again. So that's one. And the next thing is to get our RGB pixels. And if you look at these RGB pixels, each pixel has three colors: R, G, and B. And and we need to get all three of them displayed with one node. And for that, we have one node which is the color ramp. Bring this in over here, and let's add one more handle over here, and let's change this into red. This one will become green, and this one will become blue. All right, so if you preview this right now, you know it's green right now because by default what the color ramp what Blender does is the color ramp takes the average, which is the exact middle of all the values or all the colors which are over here, and displays the one in the middle. So one in the middle is green, and you know you can see that we have this gradient thing going on here. It's like a rainbow. We don't want that, so change this to constant. And now you can see that we have only two colors over here. Our blue is not over here. That's because, you know, our blue, we need to increase the amount of blue. You can do it manually if you want, or when you press this arrow over here, you can select this option called distribute stops evenly, which will distribute them along even spaces, or you can select distribute stops from left, and that will give equal amount for each color. All right, and by default we are getting what's in the middle, and that is the green. So we need to separate this, all three of these colors, along an axis. All right, so in order to get one pixel to have all three of those colors, we need to separate those three colors, and you know right now they're mixed, they're green. We need to separate them and have them displayed along one axis, and in our case it's going to be the x-axis. Like I told you, the z-axis is irrelevant, and you know the pixels usually go from left to right, they don't go top to bottom, so you don't want to use the y-axis, you want to use the x-axis. So there's a node for separating it, which is the separate x, y, z, and we're going to be separating it along the x-axis. And when you do that, you can see that it changes to red. It changes to red because, you know, now it's going from left to right. It's going from left to right like this, but it's just red right now because we haven't told Blender how big this red should go, and you know, we haven't told Blender how big each color is. So we're going to do that now. So the first step for doing this is to actually divide this thing here over here. We have to divide it into three. All right, we have to divide it into three equal pieces and tell Blender that each piece will be a color. So for that, we're going to be using vector math. All right, we're going to take a vector math node, and in order to divide it, we're not going to be using divide. We're going to be using something called fraction. So what does fraction do? A fraction is a part of something that is full. So, you know, a fraction of something is a small part of the whole thing, of the entire thing. So that's what we're going to take. We're going to take one fraction of this is going to be red, another fraction is going to be blue, another fraction is going to be green. So we're going to take this and plug this in here. No change happens. That's because right now it has been divided, but we still don't know how big each of these colors should be. How big is each fraction? We have no idea. So we're gonna assign the scale next. So duplicate this vector math and change this to scale. Where's scale? It's over here. Plug this in here, and there is no change because we have to tell Blender how the scale should be calculated. And how is the scale calculated? There are two things. One is the scale itself. We already have that, and the other is the coordinate. All right, so let's add in a new coordinate called texture coordinate. So this will tell Blender how the scale is calculated. Is it going to be along the object coordinates? Is it going to be along the UV coordinates? Select the UV coordinates and plug that into the vector, and ta-da! You got this. And if you increase the scale now, you can see that we are able to increase the number of bands over here. So this is 1 pixel, and if you make it into 2, you can see that we get 2 of those, and if you make it 3, you can see that we get 3 of those. So awesome. So this is our second step, and we have done it. So the next thing will be, you know, to make these black bands which make up the individual cells of the pixel. All right, right now it doesn't really look like pixels, it just looks like some wallpaper. So the next thing for us to do is to make those black bands, you know, those black horizontal lines which go vertically, which make up the individual cells of the pixels. You know, because right now it just looks like wallpaper, it doesn't look like pixels. So we're going to use the same scale value over here, and we're going to be making black bands. You might think it might be, you know, we can just add in like a wave texture, like this, you know, and rotate it and make these pixels, but it doesn't work, and I tried it. We're going to do it the procedural way. We're going to take it, we're going to use another vector math node over here, and we're going to change this to multiply. All right, and let's take this and plug this in over here. If you preview the scale right now, this is what it's going to look like, and if you look at the multiply, it's going to look entirely black. That's because it's getting multiplied with 0, and anything into 0 is 0, and black means null, 0. You want to change the x and the y coordinates to 1, and that would give you the same thing over here. All right, and that's cool. So next we're going to take this again, and we're going to change this into add, and let's change it into 0.5, and you can see the difference that it does. It just pushes the black away from here, and you know, brings more of the yellow into the screen, into our view. If you don't understand this, just follow along right now, and you will understand what each of these nodes do when I show it in the end, right? So don't worry. All right, now we are we have this, but we want to fractionalize it. We want to give it those individual we want to make those individual squares. All right, in order to make that, we're going to duplicate this again, and just like how we you know, broke up these bands, we're going to use another fraction node to do this. So now we have this, but more of it, you know. So I'm gonna make it to something like 10 for you to understand clearly. And the next thing that I'm going to do is I'm going to duplicate this. I'm going to bring this over here and change it to subtract. And when I subtract it, what happens over here is, you can see that we have this black over here. We have like half of the green, we have half of the red, we have a lot of yellow, and we have very little black in the corner of here over here. But when I subtract 0.5 over here, you can see that the yellow gets pushed away, and we get the black gets pushed in more. So that's what's happening here. Cool. So the next thing that I'm going to do is I'm going to be duplicating this again, and I'm going to use an absolute value. And what this does is it smooths everything. All right, it creates this nice gradient-ish texture, something like this, and this is what we're going to be using. All right, in order to make the bands. If I add a separate XYZ node over here, you can see that X gives me these vertical bands, and Y gives me this horizontal bands, and that's cool. And now Z gives me nothing because we don't have any geometry along the Z axis. And now we're going to be mixing the X and the Y coordinates to make like squares. All right, and for that I'm going to take in another vector math node over here and change it to minimum, and it's going to be X over here and Y, and ta-da, you can see that we have these boxes, and that is step 3. Yeah, that's step 3. So the next step will be to mix this and this. All right, because we want the image to be displayed over there, right? So if you preview this right now, you can see that this is what it looks like, and let's mix this with this. And in order to mix two colors, what do? You're gonna add in a mix RGB node like this over here, plug this into the first input and plug this into the second input, and if you preview this, you can see that it looks weird, you know, it's like neither this nor this. In order to change that, let's change this to multiply and change the factor to 1, and you can see that they're both at full strength. And now we are going to be mixing this with this, and that's going to be another multiply node, and let's take this and plug this in here, and something like 0.9. I like that. I like how that looks. And yep, we can next add in our emission shader over here, and if you preview that, you can see what this looks like. It looks nice. We can add in another multiply node over here, and you know, change the strength of this to 10, and change this to black So this just gives a little contrast. Reduce this 0.5, and if I mute this, you can see that it just adds a little more contrast, which we need over there. Alright, so now if you take a look at what we have, if we change the scale over here, you can see that we are changing the number of pixels which are present on the screen, but you can see that that doesn't really affect our image quality. And in the real world, if you have more pixels, you're gonna have like a super sharp image, but if you have a less if you have not too many pixels, you're gonna have a pixelated unclear image. So we're gonna have to devise a way to make the scale value affect the resolution of this image. So we're going to be breaking the image. We're going to be dividing the image into its pixels. So for that, I'm going to take and add in a vector math node over here and use divide, because I'm going to be breaking and dividing the image resolution. Plug that in here, and I'm going to be using this to break the image. I'm going to maybe put this over here and change the x and y coordinates to 1, because the factor of that is 1. 1 into 1 is 1, so we need this to multiply with the original dimensions, the original resolutions of this, so we need 1. Alright, so now you can see that there is something weird happening with the image. We will correct that with another node, which is the snap node, snap function over here. So now we need the division to affect how the image's increment in resolution. So plug that into the increment, and we're going to take the UV coordinates of the object and use that as the vector. And when you do that, you are left with this, which looks horrendous. Okay, I realized what mistake I did. So this scale node over here, we just need the scale value. We don't need the we don't need the scale function. So what we're going to do is I'm going to add in, but you know what, let me remove this and make the scale 10 over here, and you can see that the image is getting pixelated over here. And if I make this like 1080 over here and make it 1080 over here as well, you can see that I get like a high-res image. But I don't want to be changing the value over here and here separately, because I want to have the values interlinked. So I'm going to be adding in a value node over here and plug this into this scale value as well as into the vector value over here. And now I can control the resolution with this I can control the number of and now I can control the resolution of the image as well as the number of pixels with this one single node over here. And you can see that I can go from individual pixels, and I can go increase it, and you can see that as I increase it I get more quality. And 360p, you can see that you can see how the TV's legs are kind of jagged over here, and but if I go to something like 1080, you can see how it gets all smooth and everything. So go ahead, make it 4K, make it 8K, or make it even 12K that our eyes can't even see. So yeah, this is pretty cool. Now let me tell you what these nodes do. Let me show you how much control you have. Alright, so this controls the number of pixels and the resolution of the image at the same time. And this multiply node, you don't want to change the first one of this, because if you change the x coordinates, you can see that the black ones get shifted in a very weird manner. You don't want that, but you can shift the y to change the size of the height of these pixels. So if you want like really stretched pixels, you can do that. If you want like really petite pixels, you can do that as well. And of course, if you want to turn off the device, modern devices, if you turn them on, they become black, but the older TVs, they used to become somewhat greenish and grayish. So you can add in like a mix shader over here I can duplicate this emission shader. I can plug this one in over here, have the factored one, and I can make it something like a dark green like this, and change the scale to 1. So this is what I would have, and I can quickly switch between turning on and turning off. So this is a nice function. All right, and another thing is that you don't just have to have a image over here. For example, let me change this to Eevee, and duplicate this, and I'm gonna open a video now. All right, this is a video that I did, and let's select auto refresh and end frame at 250. And all that I'm gonna do is I'm gonna replace this image with this video over here and over here, so I can hide this and have this over here. And now if I preview this, oh, I'm sorry about that, goes in here. Awesome. And now you can see that I have this pixels over here. Let me bring it down a little more so that you can see it. Let's make it 300, and if I play this right now, you can see that I can even play some video on it, and it's that easy. It's super easy. And if I zoom in, you can see that the object shifts around the pixel. It's really cool. So yeah, that's about the material, and that's about the material. Coming back to our TV model, I have applied the same material on the screen, and it looks cool. I can turn the TV off, or I can turn it on. And but just one last thing that you need on the TV is that I'm gonna be duplicating this screen over here. I'm gonna duplicate it like this and bring it a little to the front, and I'm gonna delete I'm gonna remove the material. I'm gonna add a new material for that, make it a transmissive material with 0 roughness, and I'm gonna make sure that it's white. And there you go. I now have a TV screen which has that glass and everything. You can go ahead and add some solidification on the glass to make it a little thicker, but I'm gonna stop over here because this looks nice. And I can turn the TV off, and you can look how nice that looks, doesn't it? So here is the end. So here is the entire node setup. If you wanna take a look at it, you can. You can pause the video and just copy the values in the nodes if you wanna. Go ahead. So this is the end of the tutorial series. I hope you enjoyed it, and by now you should have a perfect TV model. And if you were here only for the material, come on, check out my channel, take a look at my channel, and check out the series as well. I have really good content over here. And if you like this video, if this video helps you, please give this video a thumbs up and let me know your thoughts in the comment section below. And if you like my content, if you want to see more good content, please give my channel a subscribe. That would really help me. And I'm getting excited for the 1K subscribers milestone. Yep, I am. And yeah, I'll see you in the next video. Goodbye.